Hello viewers, in this video I will draw the SFD and BMD diagram for the frame for UDL acting, 5 keep UDL acting and the 50 keep concentric load acting from the side and taking B and C as a fixed points. If the B and C are the pins, then what we will do, then we will solve these segments, these 3 segments of the frame as a simple beam and draw their shear force and bending moment diagram as a simply supported beam, and the no any moment will be transferred from B to B and no any moment will be transferred from C to C if there are pins at B and C. And then drawing the simple SFD and BMD diagram, we will join them. Here the B and C are the fixed points, so the moments will be transferred from B to B and C to C. This will explain you how I am now in this video. And here I will find out the reactions by taking the moment about point D and taking the counterclockwise moment as a positive. And here the VA into 20 create the clockwise moment. VA into 20 is the moment arm about point D. This VA create the clockwise moment. And 5 is the UDL multiplied by span and multiplied by half of the span. We will get the moment due to UDL. This create the counterclockwise moment about point D, so taken as positive. And 50 into 5, this also create the counterclockwise moment about point D, so 50 is the force and 5 is the moment arm about point D. So sum of all these 3 moments, this is due to reaction, this is due to UDL force, and this is due to point concentric load, and sum of these 3 moments equal to 0. We will get VA is equal to 62.5. Here the VA is acting, and now I will get the VD. The sum of all vertical forces equal to 0. The upward force is taken as positive and downward negative, and 62.5 acting upward, 5 into 20 acting downward. And here I will not take the moment arm because in this case I have taken the moment value, so apply the moment arm with the force. Here I will only take the force values. VD is acting upward, so in this equation I can find out VD is equal to 37.5. This is how we can find out the reactions. You can watch my another video how you can find out the reaction. I have explained in that video in detail. And now by taking the sum of all horizontal forces is equal to 0, I will get here the horizontal reaction is 50 kg. Only at pin, at here the pin is acting, the 50 horizontal reaction will act. At roller there no horizontal reaction act at roller. This is the frame with the reactions are solved, and now I will draw these. I will separate these members for drawing the SFD and BMDs. And what I will do, first of all, here the no moments will be transferred from B to B because here is the roller, no horizontal reaction, no moment acting over here as a reaction, so there will be no moment as a result at B, and there will be no moment and horizontal reaction at point B. But here at D the horizontal reaction is acting, so to counter this horizontal reaction the moment will act over here, and this moment will be transferred to C. This moment will be transferred from C to C. Find out this moment. We can find out this moment. Yes, how these forces came. This 60 was the reaction which is acting down upward. This here will act downward, and this here will act upward. Take them as they are. And here the 37 was acting upward. Here I will take it as a upward, and here it will act downward, and here it will act upward. This is how we can separate the members of the frame. And the moment, here the moment is acting clockwise to counter this 50 kip, and here this moment will act as a counterclockwise. This is clockwise and this is counterclockwise transferred. As the 37.5 is transferred, by same method the moment will also be transferred. Now how we will find out this moment? We can find out this moment by this member, by taking the moment about point D and taking the clockwise moment as a negative and counterclockwise moment as positive. M create the clockwise moment about point D. This create the clockwise moment about point D taken as negative, and 50 create the counterclockwise moment. 50 into 5 is the moment value. 50 is the force, 5 is the moment arm. Force into moment arm is the moment. Plus, because it creates the counterclockwise moment about point D, only these two terms will create the moment. This will create no moment. 37 will create no moment because it is passing through D. This 50 and 37 are also passing from D. So, thus we can find out M is equal to 0. Summation of these two moments is equal to 0 and M is equal to 37. M is equal to 250. This is the M is equal to 250. This is how this M is equal to 250 and 250. This M we can also find out from here by taking moment at any point at B or C. We can find out this will be as a 250. You can check it by yourself. And now I will take these members for drawing the SFD and BMD diagram. I will take the shear forces at point A. The V1 is the shear force at point A. It will be equal to reaction. Start the drawing SFD and BMD always from the left side. It is easy to draw when these type of conventions you are using, as I am explaining you in this video. The V1 is this shear force will always equal to the reaction over here, positive. And the V3, this is the V3. How this V3 came? V1 is the previous shear force minus the loading area. 62.5 is the previous shearing force over here minus the loading area. How the loading area is? 5 into 20. This 5 and 20 is the loading area. This UDL. Subtract it from this 62.5 because it is the load is acting downward. So that is why we will subtract this load value from the previous shear force. We will get the shear force at over here. This is the shear force. We will from B to C. We will move direct from B to C. Because here no load is changing, only one UDL is acting. So there will be only one type of UDL like this from B to C. And here V2 will be 0 at somewhat point. I can find out this point by slope method. This is 62 and minus 37.5 divided by 20 is the whole span. This is the slope of this line is equal to 62.5 divided by x. This is how we will find out x 12.5 from B point where the shear force is equal to 0. And this is 7.5 remaining distance. And now I will draw the BMD diagram. The bending moment M1 is equal to 0 over here. Because in this case as I have said you earlier that the no moment is transferred between B points. So the moment is 0 at here at point B. M1 is equal to 0 and M2 will be equal to M1 previous moment plus SFD area. This A1 is the SFD area, this one. This one is the SFD area, which is equal to 62.5 into 12.5 divided by 2. This is 390 is the moment value at this point. At x is equal to 12.5. At that point, this is the moment value. And now the M3. M3 is equal to M2 is the previous moment plus SFD area. M2 minus this because this is downward. So 37.5 into 7.5 divided by 2. This will be shear force area. subtract this value from the previous moment, I will get the moment at that point. Here the moment will not be equal to 0, but it will be equal to 250, because this 250 is moment is transferred from this C point to another member. Here you can see this 250 moment will be transferred from here to this member. So that is why here the moment will not be equal to 0, but it will be equal to 250. It will automatically come when you calculate, as it is here. This is how the SFD and BMD drawn for this UDL, and now I will draw the SFD and BMD for this member by the same method. This is the member. For my simplification, I will rotate it and take it as a horizontal, as you can see it now. This is horizontal member. C member came here and D member came here, and the forces are also rotated as they were. The 37 was along the member, and now here they are along the member, and the 50 and this 50 are perpendicular to the member, and here the same, they are acting perpendicular to the member, and this is the clockwise as it was here. So rotate it for your simplification and draw the SFD diagram by simple method. V1 is equal to Vc. The reaction here, no reaction is acting, so here you can see it from here. At C there is no reaction, so at the C the shear force will be equal to reaction, which is 0, and here the shear force at that point will be equal to the point load acting downward. And here, as here from C to this point no load was acting, so the shear force at C was 0, and here is also shear force 0 in this region. But here in this region also no load is acting, so the shear force will be constant. This is, and this is my SFD diagram for this shape. And now I will draw the BMD shape. BMD at M1, here it is clockwise moment is acting at point C, taken it as a positive. As you are drawing the SFD from left to right, take the clockwise moment as a positive. This is I have taken over here. This is external moment is acting, so take it as a here. And M2 is equal to M1 plus SFD area. Here there is no SFD area, so M2 will be equal to 250, which is M1 plus 0. This is my M2, which is also equal to 250, and this is my M3, which is equal to M2 previous moment plus SFD area. This is my SFD area. 250 is the previous moment minus 50 into 5. This is my SFD area. Thus I will get M2 is equal to 0, because at point D there was a pin, so that is why at point D the moment is 0. This is my SFD and this is my BMD diagram for this. I have just rotated them as they are, and this was my members that I have separated. Here no moment is acting on this member and no vertical shear force is acting on this member, so there will be no shear force diagram and bending moment diagram for this member. For drawing the shear force and bending moment diagram, it is must that either moment act or the perpendicular shear force must act on the member. Here those both are not acting, so no shear force and bending moment will be for this region. These are the shear force and bending moment diagrams for the respective members, and what I will do, I will simply join them. Simply join their baselines. BC, join the C with C and B with B, and similarly join for the bending moments. This is the frame, and this is my shear force diagram and bending moment diagram for this. Thanks for watching my video. If you find my video useful, then don't forget to like and subscribe my channel. In my channel you will find many civil engineering related videos about structure analysis, about design of structure, and about software tools such as AutoCAD architecture, ETAB, Primavera. You will find many other related videos.